Hello everyone. Anyone who is watching this live or has have just attended or watching this live after this got ended as video, right? So yeah, welcome to day 17 of 150 days of DSA. So we are solving a problem every day, and today I think the problem we're gonna solve is Roman to integer. Yeah, here we are, Roman to integer. This is an easy problem actually, right? I think I solved it, but I just have to solve this again. So one second, right? So I don't know where I got, yeah. So we'll be solving this. 1 second. This I has value of 1. Okay, I think you understood the problem which we want to solve today. Roman to integer. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. Now, for example, 2 is written as 1 and then 1 in Roman numeral. Just two ones add together. 12 is written as x11, which is simply x plus 1 1. The number 27 is written as x v I, right? So yeah, what I think is, what if it's just I think we can just have L is 50, however 5, right? 5, and then if it is a 1, it's just a 1. Now there are some cases. Okay, the case is when we have to take 2 x c cm. This is quite confusing. Cm is 900. Okay, cm is 900, xc is 90. Okay, so we have to be careful when we have something like this: xc cm and all. One can be placed before 5 and x to make 4 and 9. So there are only these, how many constants? 6, right? 4, 9, 40, 90, 400, 900. Given in Roman numeral, convert it to an integer, right? So what we're gonna do is we'll check whether we have, let me tell you what are the constants. Let me just write it so that you can understand it clearly much better. So first thing, we are given with simple things. 1, I is for 1, V is for 5, X is for 10, and L is for 50. L is for 50, and C is for 100, and D is for 500, M is for 1000. Now, I can take some things like this. Let me tell you. So, 1 IV, I can have IV, where it will become 5. I can have IX, it will become a 9. Sorry, IV would be 4, right? IV would be 4. Now, I can have here X and X and L. So X and L, then I can have it as 40. X and C will be 90, right? C and D will be 400, and C and M will be 900. What I'm thinking is, first I'm gonna check whether I have at least two characters in a string, right? Two characters in the string. If we have two characters, I'll just go and search here, right? Then if anything is matching, then I'll just add it to the answer, right? One, oh sorry, IV, IX, or any of these six. Now imagine it doesn't match, right? So what I'll do, I'll just take only one character and have all of this, right? So my algorithm will be simple. Check. First I need to store these two, right? I need to store these two. Store, let me tell you, store um, Roman string and integer in hash map. Now after that I'll just iterate through the string, iterate through string. After iterating, when you're iterating, if string has at least two characters, then check in here. Let us just take it as doubles, and here it as singles, right? Now two characters, and let me take flag has double as false. Now I'll check if two characters, let me take it as current, right? You know what I'm taking is, I'm just taking the two characters where while I'm iterating the string, so I'm just naming it as current, right? Now we'll have flag has double is equal to false. Now if doubles has current, answer plus is equal to doubles of current, and has double will be true, right? Now if has double is false, that means we don't have a double, nothing but we don't have this IV, IX, XL, XC, XD, CM. So what I'll do, if there is no double, what I'll do, I'll just increment the answer with singles of only first character. So two characters will be current, then what would be the first character? Let me just take it as first character. First character is equal to S of I. So answer plus is equal to singles of first character. That's it. And we'll return the answer at the end. That's what I'm thinking, I'm just revising, and I'm also learning with you. So if I get any error, please don't take me wrong, right? So we are storing Roman string and integer in an unordered map. So let me take n first. Int n is equal to s dot size. Now we are having unordered map character comma int, where we have singles here. So singles of I is equal to 1. I have for 7, right? 1, 2, 3, 4, 5, 6. Here I, V, X, L, C, D M. Now here 5 and 10, then 50, and then 100. What I'm thinking is, can we solve this without storing singles and doubles? I think we cannot, right? I'm thinking like we cannot uh, store, we cannot solve this problem without storing this. Now we have to store these things, IV, IX, XL and all. So doubles of IV will be equal to 4, right? So 3, again 3, 1, 2, 3. IV and IX will be, sorry, 9. Okay, here XL will be 40, XL will be 40, and XC will be 90. Here CD will be 400, and the next one will be 900. So here CM, right? And I have stored this. Okay, so, okay, I have stored this Roman string and integer. I iterate through the string, but before that let answer will be 0, and I'm iterating into I is equal to 0, I is less than n, I plus plus first. So first thing, I'll check, I'll go through this, I'll go through this only if the character's size is greater than 1. How can I check that? If I is less than n minus 1, right? So if I is less than n minus 1, then we still have 2 characters left. So string temp is equal to, right? I'm just taking temporary string. Or shall we take it as current? Yeah. Why? Because I have initialized answer place is equal to current if doubles has current, right? So string current is equal to s dot substring, where I'm starting I and the size will be 2, right? So then only we'll have, but before that let bool flag is flag, sorry, let us take has double is equal to false, right? Now if doubles has current, if doubles dot find current is not is equal to doubles dot end, then answer plus is equal to doubles of current and has double is equal to true. Now if we don't have a double, right? Okay, we don't have a double, then answer will be incremented with singles of first character. Now the first character will be nothing but character of first character is equal to s of I, right? And we'll return the answer at the end. Okay, no, we got a wrong answer here. So let me just check whether we are adding, let us take this as value, control C, value. So int value is equal to 0, and here value will be equal to this. Now here value will be equal to, okay, value will be equal to this, and we'll print the value which we got, cout value endl, right? So I think we can debug the error. So yeah, m, that's 1000. Let us take the description here. So we should get m 1000 and cm 900. Then okay, so while it is taking again 1000 here. Why? Because the the I pointer is going to m again. So what we'll do if it is not having a double? So I is less than n minus 1 if doubles dot found out, something like that, then we'll increment the I. So here instead of having like this, we'll have just I is less than n. That's it. We'll have int x is equal to 0, and here while, and even here I plus plus. I think this should give us a right answer. Yeah, here it goes. Now we don't have to print anything here, and we might be going fast. I just started this at 8 p.m. It's 8:17. Okay, it got accepted, but we are, let me calculate the time complexity. So we are iterating the string for how many times? Just one time. Iterating the string for one time, but every time looking at the hash double or single. So every time we are looking at that, we just take big of one time complexity. It doesn't matter. And doubles dot find current, can we find it or not, will be big of 1, however. So it doesn't take any time to find whether we have uh, the current or not, right? I think the code might not be much clean and clear, but it would be glad if you have understood the problem and how we are solving this. And yeah, the time complexity will be big of n, and the space complexity is big O of 1. Why? Because we are not taking any extra, or how can I say, singles. We cannot uh, big of 1. Why? Because we are not storing in terms of n or n square. Or let me just Google it. What if we store um, 12 elements or 12 key value pairs in an unordered map in C++? What will be the space complexity? Right? Let me just Google it. Yeah. Is big of n. Okay. We're going to understand the memory grows in direct proportion to the number of items stored, because realize it uses a constant amount of actual memory, but the former complexity class is big of n. Okay, the map creates an array, and I have another doubt, that will this takes will this will hash map where unordered map string comma int hash map take a big of n time complexity. That's what is my doubt, right? It will take big of L time complexity on average, where L is the length of the string current in terms of number of elements, and in the map it is big of 1 average time. What if L is fixed for only the size of current is always 2, right? I'm having doubt on this. So then time complexity becomes big of 1. constant time on average. So the time complexity will be big of 1. So that's why even when I'm just iterating here. So I didn't add that doubles has current. This one. I didn't add this find thing into that, right? If all n elements end up in the exact same bucket due to hash collisions, the program must scan through that bucket linearly, right? And let me know how the audio is. Okay, okay. Yeah, I think I have to keep it like this. It would be better, I think. Yeah. So, okay, we are good to go with the another problem. Let me just check up what's today's problem. I just attempted it lexicographical permutation. You are given two strings s and target, each of length n consisting of lowercase English letters. Then it's lexicographically smallest string that is both a palindromic permutation of s and strictly greater than target. Okay, if no such permutation exists, return an empty string. Lexicographically smallest string that is both a palindromic permutation of s. Okay, and greater than the target. I think this is hardest. Okay, yeah, let me just see how we can solve this, right? And if anyone is new to our channel, please do subscribe. And okay, I think the voice is clear now. B A and target is A double B A. Formation of S in lexicographical order. Why can't we just generate all the palindromic permutations? Right, that's what I'm thinking. Let me ask how to get the permutation. There is actually a standard template library in C++ which will give you a a permutation of a string as in C++ with stl. Sort, okay, do cout as loop through all permutations, standard next permutation, generate the permutation and store it in new string, right? Okay, acceptance rate is good. Only 50% has 50% of those who tried this problem were able to solve this, right? Okay, to generate and store the permutation, you can pass each variation into vector of string named new string. Okay, for constant string and permutation in new string. Okay, new string dot pushback s. Now let me take this. I'll just check whether a string is palindrome or not. A string is palindrome. String s. First we'll have int l is equal to 0, r is equal to n minus 1, but before that we need to have int n is equal to s dot size. Okay, Oh, okay, I just okay. Now, while L is less than or equal to R, even equal to R, no. Okay, we can do that, but no need. If S of L, S of L is not equal to S of R, return false. If not, return true. And what we do here is this. So new string dot pushback S. Okay, let us take temp instead of S. Temp instead of S. Now we don't need this at string. Temp is equal to S, right? Now we have something. It is if is palindrome. Is palindrome. The temp is palindrome and temp is greater than target will just return temp. Now if temp has become S again, then we just return false and there is no new string. Sorry, return temp. If not, we'll just return an empty string, and here return an empty string again. Sorry, I got sorry, it should be bool, right? Yeah, no, we got a wrong answer. Is generating lexicographically smallest string that is both a palindromic permutation of S and strictly greater than target. If no such permutation exists, return an empty string. If the temporary string is palindrome and the temporary string is greater than the target, then we'll just return temp. But I don't know why it isn't generating any thing. Let us just see with whether is it generating it or not for every string. B A and the output, there is no output. Okay, is it doing the same thing? Okay, so sort s dot begin and do this, but we need to next permutation of temp dot begin and temp dot end. How to store the next permutation of a string, and string s is given. String is equal to s, string next permutation. Modify new string to its next lexicographical permutation. If has next, the next permutation is new string. Okay, it will be stored actually. Has next. So why do we need any has next? But I just have to store the next permutation of a string as in a new string named as temp. That's it. right? Next permutation of temp dot begin, temp dot end. That's it. We don't need anything like this. Now it should run correctly, and no, it didn't. BBAA. Why didn't we get any other permutation? And BAAB, but it didn't generate anything like that. ACA CCA. Output ACA. The only palindromic permutation of S is ACA. ACA is strictly greater than target. Therefore, the answer is ACA. Let me say if is palindrome temp, S of L is not equal to S of R, return false. If not, we'll return true. But why isn't it returning if is palindrome temp? C out temp and L. Let us not uh, print. I think we should not print C out temp. Here we are. Okay, we will print only those. Okay, we didn't got any output. That means there is an error here. String s int n is equal to s dot size is palindrome temp. Why isn't it s of l is not equal to s of r? Return false. That's it, right? C out s and l. We don't need this. We'll call for that, and we might not get anything. Yeah, but why are we getting it? If s of l is not equal to s of r, if they aren't equal, we'll just return false. That's right. N minus 1, 0 will just return true. C out s of l, s of r, and l. C out s. C out and l. We'll just copy this again and again. I'll just doing that. Double B A A, and yeah, that's C ACA. Why isn't it checking for ACA? If it is a palindrome, and it should, okay, it is again checking for the next permutation. I think it isn't needed. No. Okay, there is some error. 1 second. I don't think this should be there, right? While we'll just do this once. We got the next permutation of temp, while temp is not equal to s. We'll just do this. Now, if temp is palindrome, then we'll just return. We'll just return, remove all of this. This should work. Okay, A B B, A and B. Okay, A B A B. What happened to A B B A? What happened to A B B A? Why isn't it giving me? It should give me actually here. The error is here. Yeah. Why isn't it checking for A B B A? It should return it, right? It is a palindrome. Okay, that's first thing. It is a palindrome. If it isn't a palindrome, it should output where the palindrome is false. Okay, but wait a second. We aren't returning false here. We're just printing. Yeah, that's the error. A B B A and A are not equal. One second. A and A are not equal. S of L is not equal to S of R. A B B A and A are not equal. I don't know why is it giving me a wrong answer. S of L and S of R are not equal, then we'll return false. But S of L and S of R are equal. You see this error? A and A and B are not equal. I agree with that. B and A are not equal, but A and A are not equal. Yeah, one second. I did some error if L is less than R, N is S dot size. It should not print it like this, right? If S of L is not is equal to S of R, we should return false, and we are doing it, but it is even taking it when it is equal. Just taking this outside. S of L, oh my god. L should be incremented and R should be decremented. Yeah, that's the error. But okay, yeah, I got it. Here, let me tell you, when it is A double B A, I think we don't need anything. Yeah, we need this B double A B. Yeah, it should work. But what's the time complexity here? We are taking the next permutation and we are checking is palindrome. How many permutations does a string with size n will have? What is the time complexity of next permutation? a string of size n, then there are three permutations. So yeah, there will be n permutations, right? So string of size n, string of size n, there will be there will be n permutations. Now we have n permutations. Okay, now we are having big of n time complexity. Now big of n time complexity of next permutation, amortized average case big of one constant. In most cases the function only needs to have the last two or three characters over a full cycle of generating all permutations. The average number of operations per call is less than 3. Worst case big of y. In the worst case scenarios, it is going from f. In the function has to scan and reverse the entire string of length n. Summary: if you use in a loop to generate all unique permutations of a unique string, the overall time complexity will be of n into n factorial. So big of n into n factorial with the time complexity to generate all permutations. Okay, that's the time complexity. Now we are checking the palindrome, whether it is a palindrome and whether the temporary string is greater than target. But let me tell you, is palindrome, there would be no, there might be, there, the worst case would be is palindrome is n and it will be big of n. And what if the size is 300? So 300 into 300 factorial will be much more. Big of 2n will be 600. Big of, I'm just guessing and might work. Might, okay. Input as target is a, output I got it as empty string. Let us just say if s dot size is equal to 1, if s is less than target, if s is less than target, return empty string. Else if it is greater than the target, then return s, right? Let me use the test case. No, output is okay. Is s less than target, should return an empty string. Okay, return s here. I don't know, I'm just I didn't write return here, that's why I got a wrong answer. Again, here you see this test cases, there are many edge cases for this hard problems again, okay. Output is an empty string, but we expect bb. The target is AA. Just see if you is s is greater than target and is palindrome as, then return as itself, right? Just, my god, s is equal to target and is palindrome of s written as. No, no. Let me just take this. Where did I get the wrong answers? Take this again. Take this again. Okay. Let me run this first. No, it's okay. I submitted it. I migrated TLE. See this? If s is greater than or is equal to target, if it is a palindrome, then we'll return s. We can just use this, right? You don't do this. Let me see. Yeah. Let me tell you one thing. All of these should be stored in a vector of strings. Why? Because we need lexicographically smallest. So here we have strings, but before that we'll do one thing. If it is palindrome, we don't return temp. We'll push temp back into right. Now for auto current in strings, if current is greater than target, then we'll return current. Okay, I think it's clear. Okay, if the temporary string, the permutation is palindrome, then we'll push that back into the strings, palindromic strings, right? And we'll just, the temporary string will be having the next permutation, and before going to strings, we'll do one thing. We'll just sort these strings. So sort strings dot begin, strings dot end. Yeah. Now you need to use the test case. 1 second. Let me 1 second. Yeah, I can use the test case now. 1 second. Why didn't it sort? That's, I think, the current string is greater than target, then we'll return current, else we'll return empty string. 1 second. The error is here. Right, if s is greater than target, you know, these kind of question, screw your brain. We have to check here if target is greater, sorry, is lesser than s, and is palindrome, is a palindrome, then we'll return s. I think this should work for test case 6. Yeah, thank god. ABBA. Gandhi Linga 1347. Can you do it in Python? I'm used to C++, brother. This is quite simple. That's the same syntax. I'm just creating a next permutation and pushing all those into strings vector only if they are palindromes. I think I can push. They asked us strictly greater, but these questions. I got B double A B, but it should be A double B A. let us do one thing. But you see, strings dot push back as, yeah, I think this should work. We are good to go. If S is palindrome, this should might exceed the time limit. Yeah, at least we got to know that we are going in a right direction, right? So we're checking whether the temp is palindrome or not. We can check if temp is less than or equal to the target. We just continue. We just do one thing. We just have the next permutation. Here, let me use third test here. Let me use third test case. The time limit exceeded again. Okay, there might be a way to solve this. You don't have to iterate here. that s is greater than target and is palindrome, then we'll just sort it and return strings of 0. You know, 1 second. I think there should be another way to solve this problem. Let's look at the topics. Two pointers, string. This one if at most one character has an odd count. Outlast string. I just can solve this afterwards, and I'll also be uploading a video on this, how we can solve this hard problem. I think that's all for today, and I don't know why is this message got retracted. Okay, I don't know why, but thank you everyone for attending this live session. We'll just have some discussion here. You can ask your doubts. Now let me just open this. Thank you everyone who have attended this live session, and if you have any doubts, you can just ask me. We have to hit like 1200 subscribers by the end of this session. I hope we'll do. Yeah, thank you. I'll just send my LinkedIn. Target for today's live stream subscriber. bro. Hi, Hari Subramaniam. How are you doing? Yeah, I'm just in front of the screen, but I just turned off my video and I turned off my audio. Still, we are still at 1169 subscribers, right? And this is day 17. We just started this, and it's been more than 2 weeks already, right? So I hope we'll be ending this live session at 10 p.m. exactly at 10 p.m. Yeah, so if you have any doubts, please let me know. And if we don't get subscribers, I think, yeah, if we don't, if you don't have any doubts on the problem we just have solved, we can just end this live session at 9:45. It's already 9:42, right? Yeah. How are you doing, Yashwant Kumar? How are you doing?